Just staring at the backpack. All right, so see, isn't this going to be like really funny? Is not the right word. Terrifying if all this stuff we're joking about turns out to be like legit. Um, oh, by the way, how are you feeling, Beyonce?
I'm fine.
I heard maybe some dehydration would be.
No, I heard knocking a TV.
Dehydration, sensitivity to light. I find him curled up in the fetal position in the gutter outside my house last night.
That was about an hour ago.
Actually, years ago, that actually did not happen to him last night. But, well, not at least not in my gutter. But years ago, I did have a student that was afraid. He was a commuter, was afraid to call his parents. Calls me at like at 3 a.m. He's drunk. He's lost. he's naked. So I have him start describing where he is. Okay, he's on Locust, west of 43. So
Say good luck.
So I go and pick him up like at 3:30 in the morning, and he's like hiding in the bushes. He was like all paranoid. I don't know. I don't know if he got roofied or something. He was on something. That was a very interesting evening when I had to take him to his parents' house and smooth things over while their naked son was wandering into the house.
Did you bring him clothes?
Huh?
Did you bring him clothes?
I didn't. When he said he was naked, I thought he was like out of it type thing, almost like joking. Totally not joking. So no. I had a blanket in the car that I gave him. So I mean, otherwise it would have just been creepy.
Right?
All right.
Why are you wearing your shirt?
If that was a female student, that would be entirely different.
I probably wouldn't have gone. I probably would have like called their parents or something like that. Yeah, even though it seems to be a double standard, you got to be somewhat careful. All right. So last time we were talking kind of where Swift fits in the world, right? And I probably mentioned right at the end of class, probably is when we hit the punchline of this thing, that Apple really did not create Swift to improve upon Objective-C. They really created Swift to try to encourage the Java programmers to come over to Android, or Java programmers to leave Android and come over to iOS, as well as a lot of these web developers to stop making cross-platform HTML5 based mobile applications and come over and start writing native stuff for iOS. Yeah.
Is there anything in the new Swift language that you can do that you couldn't have done in Objective-C, or maybe it's easier?
Well, it's I suppose the answer to both of those things is yes, but it's like a qualified yes. If we start kind of, so let me try to answer some of that and swing back on it a little bit, kind of with our on the next slide here. So if we say features of Swift, so kind of what was Swift trying to do? And one thing, so kind of to your point, is similarly to what Java did relative to C++, where Java tried to look at some of the things that programmers used to have to do in C++ that just didn't make sense anymore. So it kind of took some of the decision-making out of the language. Swift took that even a step further. So Swift really had a goal of minimizing the amount of stuff you have to type. Okay? So for instance, they've omitted semicolons. No semicolons at the end of lines. They've omitted a lot of opening and closing parentheses. So some of these things are not illegal. So for instance, semicolons are allowed in Swift, but not encouraged. It'll take you a little bit, especially if you've been programming in semicolon-based languages for a long time, or I wouldn't say a semicolon-based language, but you get what I'm saying. Languages that use semicolons to break up statements. it's going to be a little bit difficult for you to kind of transition to this idea of you don't finish a line with semicolon. But you know, it eventually will go away pretty quickly. But Swift doesn't require them. Although I will say as a caveat, just something to keep in mind as you're writing your code, sometimes you'll get some kind of weird behaviors from Xcode, the IDE we're going to use in here. It's not quite as... expect there to be some bugs every now and then. I would say it's pretty solid, but when it comes to the language, with the language being fairly new, and those of you who are taking the 470 class will kind of learn this other side of things, the compiler and the interpreter for this language, which is kind of both, it isn't as evolved. It isn't as debugged as other compilers may be that have been around longer. So there might be some situations where you create a line of code and the line of code looks like it should be fine. It's giving you some stupid error that you must do this, that, or the next thing. You press enter at the end of the line, all of a sudden it works. Stuff like that. So just in the back of your head, just be aware that you may run into little quirky things like that. It's not super common. It's not like it's going to be this overarching thing that maybe it's a mistake, maybe it's not, but if you ever do bump into something that looks right to you, just go to the end of the line real quick and try to press enter and see if you can convince the real-time error checking thing to redo whatever it last did. All right, so one of the goals of Swift is to minimize the amount of stuff that you have to type. Fine. It's kind of a cool thing. If you just think about the evolution of languages, so for instance, and I like to look at Objective-C for this as a good starting point. Let's kind of do this. A good example of this, so most of you are Java developers, so let's kind of write a constructor in Java. So if we have a class called fraction in Java that's controlling a numerator and denominator or something like that, in Java we would have the constructor might look like this. Fraction, int num, int denom. Let me left justify this for my own sanity. And we might say this dot num is equal to num. This dot denom is equal to denom. Denom. Do it. Okay. So we might say something like that in Java. Okay, where we can assume that inside this class we have some fields up here for int numerator, int num, and int denom. Make sense? All right. So now let's look at the equivalent in a language like Objective-C. And I like to use Objective-C. If we go back to this thing, I've advertised it last time as kind of being our more archaic language. I think I probably also mentioned something along the lines that there's many aspects of it that I like. In fact, I might even say Objective-C is among my favorite languages. But Objective-C is really, really good to show something that is really important to understand that's there, but we can certainly appreciate some of our modern languages don't make us type it. Okay, and so you'll see this here in a second. So let's say we were writing this, the constructor for the fraction class in Objective-C instead of in Java. So not Swift, Objective-C. So naming conventions in Objective-C typically I mean, you could name it fraction if you wanted to, but it's usually like init with numerator and denominator, or it has the word init in it. Not because it's syntactically required to have the word init. It's a naming convention. So we're going to say init, actually let me just, with numerator int n. Well, here, we'll just keep it consistent to match. And denominator int denom. And then we'll say self.num, self.denom. Something like that. All right, so these two constructors do the identical things. All right, this is Objective-C, a much older language. This is Java, a much newer language. Now, having said that, first of all, we notice in Java, when I taught you about constructors in there, one of the things we said, what's the difference between a constructor and a method in Java? You can just look at this and probably answer the question by looking at this. What do methods have that this doesn't? A couple people in here have an excuse to answer that because they aren't in week 3 or 4 of 250 yet, but doesn't return a value. I was going to say the rest of you idiots, except for Levi, of course. Yeah, doesn't return a value. Methods don't return, or constructors in Java don't return a value. Why not? In Java, how are constructors used? Say this again.
Set up an object one time.
Set up an object one time, and they're always used after the new keyword. So if I was creating this fraction, I might say fraction f is equal to new fraction 1, 2. Something like that, right? Okay. So here's my call to the constructor. Here's me passing the 2 parameters. 1's coming in for num, 2's coming in for denom, and constructors always follow the new keyword. What is the new keyword in Java? Or C++? Or C? Well, actually, C didn't have the new keyword. Let's just say C++ or C#. What's the new keyword do? I mentally reiterate the idiot thing.
Get a new place in memory.
New memory address. New keywords are real estate agent. That's how I taught it, right? Okay, so this guy's job is to go find a place in memory. All right? 100% of the time, the new keyword returns a memory address. 100% of the time. So that means that 100% of the time, a constructor will return a memory address. If it always returns the same thing, does it make any sense for us to waste our time typing in a return type? No, it always does the same thing. We don't have an option. So in these older languages, we're really just going through the motions and typing typing something that we have to type anyways. All right. Now, having said that, I actually like using Objective-C as a way of teaching this, not because Objective-C is better, but it's showing you some stuff that's happening in other languages. For instance, so first of all, we notice that in the Objective-C version of this, we have a return type. Okay, the return type here is an ID. In an older language, we could look at this as a void pointer. Is what it would actually be, but in Objective-C they call it an ID. So this says return type is a memory address. That's essentially what that says. Okay, the little dash says it's an instance method. Objective-C hyphens are instance methods, plus signs are class methods instead of static and non-static. Unimportant. All right, but no return type versus having a return type. Something else we see here. And in Java, we're not used to this. In Java, we're used to the existence of this keyword being assumed, right? It's just there for us. We didn't have to do it. We don't know where it came from. We just know that Java magically gave it to us, right? So what I'm showing you here in Objective-C is self is the Objective-C equivalent of this. It's how an object refers to itself from within itself, okay? In Objective-C, we see the variable self being defined and the variable self being returned. 100% of constructors in Objective-C start with this line and end with this line. 100% of them. So why are we wasting our time typing in 2 lines that we might as well just cut and paste to begin with? Every single time I write a constructor in Objective-C, I start off with these 2 lines and then just press enter between them and start building the sandwich. Because those are always the first and last line of your constructor. So does it make sense to omit it? Sure. But if you didn't know it was happening, we might not really appreciate where this keyword came from. I promise you that as part of this constructor, this is getting a value. So inside here we have a magical invisible line that says this is equal to super, like that. And whose fraction's super? Whose fraction's parent? As far as you can tell from what I've written here. Object in Java, right? Okay, so at the very top level of any object-oriented language, and we're going to learn this from an implementation perspective in the 470 class this semester, okay, very top level, there must exist a starting point, okay? So the starting point in pretty much all of our object-oriented languages is going to be some class named object, or in Objective-C it's called NS object for next step object. In Swift, it's object. C#, it's object lowercase o. Yeah. C# has a bunch of uppercase equivalents. Yeah. But in any case, they all have this core object at the top. And that core object contains within it the mythical magic that creates the starting point for a object in that language, the base for an object, kind of like that abstract keyword we talked about. Whenever you need to create an inheritance model and you need something very generic at the top, the most generic you can get in any of these languages is object. All right? That guy has the magic in it that builds the initial starting point for this keyword. Just like super, this is the parent of this class in Objective-C. We're calling his init method, which does who knows what, but one of the things it does is return the memory address to this copy of an object. Right? So the punchline here is we're seeing this happen and we're seeing this happen 100% of the time in Objective-C, along with this. Okay, always has a return type. All of those are, as long as we appreciate that they're there, all of those are wastes of time. Okay, they're not necessary, so why should the programmer be burdened with having to type those? All right? But again, very important that as computer scientists, we understand that those things are there. Because it helps us understand where kind of this and self fit in the big world of things. All right, so Java goes this route. In Java, we have a couple of requirements. One of the requirements is that the name of the constructor must identically match the name of the class. So if the class name is fraction, capital F, constructor's name will be fraction. Now let me show you the equivalent constructor in Swift. I'm actually dumbing this down a little bit because I don't want to introduce something called optionals yet. So this would be the Swift equivalent. So one thing we see in Swift as being a requirement is constructors are always named init. No more, no less. They're named init. That's the constructor. Now we can have more than one constructor that constructs the object but maybe takes in a different number and or type of parameters. What's that called? Polymorphism. Polymorphism. When we have the same function, the same name, that takes in a different number and or type of parameters. So we can have 5 different constructors all called init as long as they take in a different name or combination of inputs. Okay? But getting back to this, one of the goals of Swift, minimize the amount of stuff you have to type. So they've taken Java almost as the model for that, where Java's already reduced that stuff. And they said, okay, now you get to type even less. Okay? Let's see. Now, kind of going along those lines, let me just show you another construct in Swift so we can sort of kind of introduce parts of the language. And this is actually kind of a interesting, well, I find it extra interesting because it proves that I'm right a shocking number of times. Remember when I first taught you about if statements and loops and things like that? We talked about the opening and closing curly braces, and I said you should always use an opening and closing curly brace because it's never wrong. But technically, conditionals and loops only require one statement following it. So if you only had one statement to say, you didn't actually have to have the opening and closing curly brace. Probably talked about that when we first introduced the syntax in Java for if statements and loops. But then I always recommend always use the opening and closing curly braces because it looks better and it's never wrong. Kind of remember me saying that kind of stuff? Well, Swift agrees with me. So much so that Swift requires the curly braces. Keep in mind, this is after I've announced its goal of minimizing the amount of stuff you have to type. They've decided that those are things that you have to type. So in Swift, if you're writing an if statement, it's if Boolean expression true stuff, optionally false stuff. Okay, so it looks pretty similar to Java. One caveat here, while this is accurate syntax, the parenthesis is not required for if statements in Swift. And we'll see all this stuff again. I'm mostly showing you examples that kind of support some of the goals of Swift. All right, so Swift said, hey, why have the opening and closing parentheses? They're always there and they're really meaningless to what this line says. But by the way, you always have to have the curly braces. Okay. So, minimize the amount of stuff you have to type. One goal. Another goal. Look like Java. I don't think Apple would admit this. I don't think you could, if you went to Apple and said, hey, did you try to make Swift look like Java? They would probably say, oh, no, it just kind of happened. They tried to make it look like Java. Who's Apple, or who's Apple after? They're after more iOS developers and Mac OS developers. Who are the competitors? Java developers who are writing Android crap, right? So they're going to go after them, bring them over. What else does it look like? It looks like C#. Why? Because C# looks like Java. Kill two birds with one stone. All right. What else? Look like web languages. That would be things like Python, Ruby, PHP, those languages. So it looks like those languages. Why does it look like all of these languages?
So it's more familiar for other people that were using them.
Okay, so I kind of, I guess, misasked the question. That's certainly a correct answer to that, right? Yeah, I mean, it looks like it because Apple wants as many people to be able to adopt Swift quickly as they possibly can. Okay, but when we look at this lineage tree here, why does this guy look so much like this guy, and all of these guys? Could we also say it looks like C++? We can. It's all because all these languages came from C. So really, Swift looks like C, or C++, it's clearly object-oriented, with a whole bunch of the extraneous stuff you used to have to type removed. Make sense? All right. So what was Objective-C all about? We just looked at it, and even though it was not completely foreign to us, it clearly looks different than those other languages. It has some uniqueness to it, right? So what was that all about? Why is Objective-C different? What do you think? This is where the breakup occurred right here, right? So if Microsoft went here, Apple went here because they didn't like Microsoft. They had to be different by definition. So they basically grabbed a language, perfectly usable language, perfectly acceptable language, but realistically from a syntax perspective, can you look at Objective-C and say there's any sort of real benefits to it over C++? I mean, you could argue which of the two syntaxes you might prefer, but I don't think that you can come up with real examples of how Objective-C is clearly better, right? And Apple typically tries to spin things like that, right? It's like, oh, the other guys made a mistake. They were going down the wrong path. So instead, we're being the smart. We're going down the smart path because we're Apple and we're never wrong. But it's interesting how, I'm going to scoot this over a little bit, how everybody else followed the lineage of C and C++. Nobody else followed the syntax constructs of Objective-C. So finally, Apple has to say, well, we really want to get these guys over here because, we're not upgrading. Well, they make it look like they're upgrading this language over here. But we talked about last time that if you're already programming for Apple, you're already drinking the Kool-Aid. You don't have a problem with Objective-C. Objective-C is perfectly acceptable. In fact, it probably makes you feel better as an Apple fanboy because you feel like you know this like foreign secret language that the other lesser developers don't understand. Right? Doesn't that sound like a Mac user? Well, I mean, these are all truths, and we see back the historical significance of the war between Microsoft and Apple. More recently, now it's Google and Apple. Microsoft really isn't in the war anymore. I mean, C# is a perfectly acceptable language, but nobody's trying to knock them. I don't think Google or Apple are worried too much about Windows Mobile. I don't think either of them are worried about that. Okay, so C#'s non-competitor, but Apple would love for people to stop writing stuff in Java. And a prediction I made last year, and I think actually Google has sort of kind of insinuated they're going to be doing this. Google has a language called Go. I predicted last year that Google was going to convert their Android API to the Go language. I think you're going to see Google, no longer people won't be writing Android applications in Java, they'll be writing it in Google Go. And I bet you they make that announcement here probably in the next 6 months.
What should be September?
More like, at the same time. So kind of going the Swift route, kind of because now what they have to do is they have to give off that perception of kind of a new evolved language that, to compete with these other new languages. So, Swift, while it looks a lot more like Java and these languages over here, also has some legitimate performance benefits, some legitimate good stuff. It's a very modern language. It's been able to look at all this stuff that happened historically and take all that into consideration and say, okay, well, we're going to make these changes. Makes sense, right? It's the latest, greatest computer, if you will, which is probably going to be faster than the latest, greatest computer from 2 years ago. How old's Java? When do you think Java came out? Guesstimate. Huh?
Before I was born.
Probably not. 1995-ish, probably.
When I was about.
If you look it up on Wikipedia, it might be 93 or 94 when it was actually put in some research paper or something. But somewhere in the mid-90s there is when Java was really released. I would guess 95. But in any case, that's not yesterday. So is the budget pleaser computer you can buy from Best Buy today a little bit faster than the top-of-the-line computer from 1995?
Maybe. We got a couple Celerons there.
Top-of-the-line computer in 1995 was a 486SX 25 megahertz computer. Your Celerons are better. Go ahead. 95? I told you just a few minutes ago, I'm rarely wrong. It's a curse. Just ask my wife. By the way, did you see those flowers I rolled over?
I know when you're wrong when you run over flowers.
That was actually really, really funny. If you guys didn't follow that on Facebook, I was backing the boat into the driveway. I'm in a rental car right now. So the mirrors are positioned a little bit different, but it's not that bad. But there was a car. I usually pull forward once I get straight to just get completely straight because my driveway is on a hill. And her car's there just to make sure I don't bump into her car. Well, there was a car wanting to go by in front of me. So I decided, I could pretty much make it. I was already in there pretty straight. So I just kept going, and it turned out that I had about half a wheel along the flower bed. Went into the garage just fine. Didn't realize I had done it. So I had half a wheel on there, but on the outside of the boat trailer is like this steel pipe that just did clothesline straight, straight across. And she was telling me just like the day before how proud she was of these flowers compared to those same ones she planted last year because they really had bloomed a lot and were really filled out and stuff like that. So I decided when I went in to tell her, I decided to spin it. So I told her, I said, look, I got good news for you. And she said, what? I said, well, I mean, you don't need to spend so much time watering your plants. It's good. I mean, I say it's a reduction in labor, right? She didn't agree with that. Yeah, I figured they're not perennials. They're annuals, so they're gonna die in a month and a half, anyways, right? Just put it out of its misery a little sooner. It's so hot out right now. They probably liked it. All right. So getting back here. So features of Swift. Wants to look like all these other languages, as well as minimize the amount of stuff you have to type. One of the reasons it wants to look like these other languages is A, regardless of Apple's intentions. Our modern languages are all based off of C, not really based off of that Objective-C syntax. So really this is Apple jumping on the bandwagon with everybody else and saying, hey, let's bring our languages underneath kind of the same umbrella and not be this outsider over here. And it also has the additional benefit of maybe being able to convince some people to come over to the dark side. Now this is where Swift gets a little bit confusing though. Notice that I said that it looks like the web languages. So I'm going to throw another line in here. We're going to say that Swift acts like Java/C#, not like the web languages. All right, and this is kind of an important caveat. If you remember back to one of the early slide sets you saw probably in CSC390, one of the slides said there are two kinds of programming languages. We have interpreted languages and we had compiled languages. We had another slide that says there are two kinds of programming languages. We have loosely typed and strongly typed languages, right? So loosely typed languages do not require us to define a type for a variable before we use it. Strongly typed languages do. All the languages over here are all strongly typed languages. So let's throw that out there. These are all strongly typed. Similarly, all these languages is 5 S's easily, are all compiled. Okay. All the languages over here are loosely typed and interpreted. Okay? One is not necessarily better or worse than the other. Kind of right tool for the job type thing. But these do have implications when it comes to using the languages. So something that I'm an advocate of is programming is the skill set. The language isn't really necessarily important. But, let's think about this from, I guess a tool perspective. I'm not really necessarily a tool guy, but we all know how to use like a screwdriver, right? Okay, or we all know how to use one of the wrench things. Now, my understanding is we kind of have two different measurement systems. You have the metric and then what, SI? Those the two? Okay. Huh? Yeah, imperial. So, even though they might look the same, they're a little bit different in measurement, right? Right, so the idea here is that by knowing how to use a wrench, we can use either of those. But picking the correct wrench for the application we're using it for is going to require us to have a little bit more insight about which size bolt we're working with, something along those lines, okay? One is not necessarily better or worse than the other, even though it's my understanding there's some weird people out there that think one is better than the other, probably the British. Actually, I know a British guy. He knows nothing about the metric system. And the Australians got it right because they just decided to go with the imperial system and just, like, we disagree with Americans. Everything's fine. So, in any case, loosely typed versus strongly typed languages would be a similar type thing. From a programmer's perspective, we're going to apply the exact same programming competence to either one of these, just like we would apply the wrench using competence to either of those wrenches. But knowing that it's a metric wrench or knowing that it's an imperial wrench gives us maybe a little bit of insight about what we might be bumping into when it comes to the stuff we're going to be interacting with. Similarly, knowing a language is loosely typed tells us a little bit about how that language might look or might act. Strongly typed, how it might look, how it might act. What this ultimately comes down to for us is how variables work. Okay, so this gets back to our idea of how do human beings solve problems. We use memory, asking questions, and repetition. Programming languages provide these three things through variables, conditionals, and loops. So we start off with variables. So every single time we're going to learn a brand new language, and I mentioned this to you when I first taught you Java, that if you can learn how to make variables, ask questions, and write loops in any language, you can already solve a broad classification of problems in that language. So we're going to start off looking at Swift from that perspective. And this is where the rubber hits the road. So variables in Swift. Syntax. So let's look at syntax of variables in Java and variables in Python. Int a is equal to 5. So I'm defining a variable named a of type integer, setting it equal to 5 as a starting point. That's Java. Python, var a is equal to 5. That's Python. Strongly typed, compiled. Loosely typed, interpreted. Now Swift. Actually, leave that off. So Swift sort of kind of looks like Python. Sort of kind of acts like Java. So we would say the syntax for a variable in Swift is much more similar to Python than it is to Java. But I'm telling you that Python is a strongly typed and a compiled language like Java is. Make sense? Now, what happens if I say a is equal to Mike in Java?
It will die.
Error message. Cannot squeeze a string into something that was built to hold an int. That's what a strongly typed language is. If I'm in Python and I say a is equal to Mike, what happens? No big deal. You wanted to have a number 1 second, now you want to have a string? Cool with me. This is one of the reasons why interpreted, loosely typed languages are slow. Because now we have to bring an extra dude in, known as a type inference engine, to look in our variables before we use them. All right, so if I bring out the magical, I think there's actually a game show that did this. I saw sometime where they have like a box, and the box is all blacked out on the front so you can't see it, but the people in the audience can see what's in the box. And these people are reaching their hands in as like part of this challenge, and like sometimes it's like scorpions, and sometimes it's like little teddy bears, but they don't know what it is, so that's their way of testing. Okay. Well, so we need to have something to test what's in these, what's in our variables before we're going to actually use it. You don't want to try to do math with something that's not mathable. My word, good word. All right. So that's where this type inference engine comes in, which is an extra step. It makes things slower. Okay, but it gives us the flexibility to reuse our variables for various types. All right, maybe a reasonable trade-off. Who knows? All right. So again, Swift looks like this kind of language. So for those people who are coming from this world over here, they might expect that since Swift looks like this, it might also act like this, but it does not. It acts like this. Okay, we get an error. Why is that? It actually is a little bit stupid, in my opinion. I don't know why they, well, yeah, it's stupid. I'll explain here in a second. Why didn't Swift go with this syntax for defining variables? What ends up happening here, if I say var a is equal to 5, right as soon as I put 5 in there, it earmarks a as being a variable of type int. So a type gets associated with it. Okay? Now, what I shouldn't do in Swift is that. I shouldn't just say var a and then later on say a equals 5. It will technically work. That would be very bad programming practice. So not until I actually put the 5 in a does it become an int. It's a generic before that. Okay, but we're going to call that bad programming practice, so never do it because bad things will happen. It's like the Ghostbusters crossing the streams thing. All right, so does everybody at least get that joke? Anybody here never see Ghostbusters?
Go home. Watch that.
What is wrong with these kids?
Like, I thought you said never cross the streams, Ray.
I haven't seen Hackers already.
No, it wasn't. It was Egon, right?
Egon,
Like,
yeah.
it would be bad. Like, what does that even mean? Okay, so this is considered, well, I was getting ready to say why Swift is stupid. I don't know why Swift didn't use this format for defining variables. There's nothing wrong with it.
Why don't they just follow the C# way of doing it and have both?
Oh, C# really doesn't have both. C# allows for both because they both compile the Microsoft Intermediate language,
Right.
but the syntax for the language. And actually, that's even worse to have both.
No.
That's just confusing.
No. Definitely confusing.
I mean, that's why Visual Basic is garbage as a programming language because, you know, Visual...
That's an entirely different...
I can
We're not
typecast an
even-
integer into an ice cream cone in Visual Basic, and somehow it'll make sense what the output is.
That's just cheating, okay? You can't bring it to Visual Basic.
So here's the issue with variables in Swift. So they look like loosely typed variables, but they act like strongly typed variables. All right? In Swift, we have something called optionals. A common mistake that we make in other programming languages is something along these lines. So let's use Java as our example. So I say int a, and then I say system.out.println a. Okay? I've actually used a variable before I actually gave a variable a value. Big no-no. Now, integers get a default value, but we should never rely on that because we don't know what the default value might be. I think it's usually 0. But never rely on default values. If you want it to be a 0, you put a 0 in there. Okay? But this would be a common mistake that programmers make. They create a variable, forget to put a value in it, and then just start using it. And Java is usually pretty good about giving warning messages or error messages saying variable may not have been initialized, something like that you've probably seen before. In a little bit older language, C++ did not do that. Here's your output. We'll see what's in there. Hope for the best. Okay. Sometimes you get weird memory addresses. Whatever used to be in there is what you get. Sometimes ints always, I think in C++, always defaulted to 0. But if you were dealing with object type stuff that you didn't initialize, you would just get whatever used to be in memory there. Because we typically don't erase what was in memory. We just mark off that memory is currently being used, and whoever comes up behind him is just going to overwrite what used to be there. Okay, so optionals fix this problem. So in Swift, what you might say is var a is of type int. I'm going to use this question mark syntax, which makes it an optional. So this says that a might not have a value by making it optional like that. But by making a variable optional, it also now has the side effect that we must do what's known as must unwrap. Or if it makes you feel better, Abe, you can think of it as undressing. You must unwrap the variable before using it. Okay, and what unwrapping is essentially asking the question, if A is not equal to nil, if it's not equal to nothing, then I can use it. That's the act of unwrapping. So what does that mean? If A not equal to nil, you can use the var. That make sense? So that's the act of unwrapping. Now that's all fine and good, so it keeps us from making some of those errors, but at the end of the day, and I realize we're out of time, but at the end of the day, once you've gotten pretty proficient at programming, that's typically an error that you don't make that often. Okay, so next time we'll start off by talking about overriding optionals. And I will very likely give you your first assignment on Friday. Well, your second assignment. First assignment was already due, and your class isn't graded yet, but it will be today. All right, questions, comments, concerns, bribes. I will see everybody on Friday.
Actually, another question. So when you have it the optional like that, yeah, go back that one. Could you just say var a and then set it equal to a string and then it would automatically change it, or would it not because you did the int string?
Oh no, it would not automatically change it.
It would not automatically.
Yeah, you can't. Yeah, if you tried to set it to a string and then also claimed it was an int, yeah, it'd be bad.
Just want to make sure.
But it would syntax error, yeah. Yeah.